Welcome to another lesson with Dr. Hill. Today we're talking about chemistry again, our organic chemistry series, and we're going to be talking about a new type of compound, but it's very similar to the previous ones we've been talking about, the cycloalkanes. Again, this is another family of compounds, a homologous series as it's called. And in this particular case, what happens is the carbons get themselves involved in a ring structure. Let me show you how that works. I'll grab my old model here, and we'll attempt to show how this works. So if I take this model here, what we can see is this is a standard alkane. All right, 1, 2, 3, 4, 5, 6, 7. This is heptane. There are single bonds everywhere. It's saturated. There's no room for any other atoms in this structure, so it's saturated. But let's imagine what happens if I take this hydrogen away, and at the other end I take away this hydrogen. Okay? And what can happen is, if I get this nicely looped around, is that carbon can join to the carbon from one end can join to the carbon from the other end. All right? So now what you see is we have a ring structure. All right? It's got 7 carbons in it, but it's lost 2 hydrogens. So when we talk about our general formula, remember when we talked about the alkanes, it was CN HN 2N plus 2. Well, in this case, we don't have to do the plus 2 anymore. It's all become simpler. All right? We'll look at that in just a second. But there you go. And this structure here is called 7 carbons, and we just stick cyclo in front of it. Cyclo means ring. So cycloheptane. Yeah, heptane, saturated, cyclo, ring shape. General formula CnH2n. All right? Let's have a look at the board over here. Okay, so it's another homologous series, the cycloalkanes. The carbons form a ring. That gives us the cyclo name. They are saturated, so they're still alkanes. They're still considered to be alkanes. And the simplest one of these has 3 carbons in it. You can make a ring out of 3 carbons. You can't make a ring out of 2 carbons. You can't make a ring out of 1 carbon. So the simplest of the cycloalkanes is cyclopropane. Cyclopropane has been used as an anesthetic in the past, and some people suffered consequences from it, and also it was very explosive, so they decided not to use it in the end. But it's good to know that. All right, so back to the board. We need to know about the 3 carbon version, the 4 carbon version, the 5 carbon version, and the 6 carbon version. And they are named just exactly the same way as before, except cyclo in front. So cyclopropane, cyclobutane, cyclopentane, cyclohexane. All right, and the general structural formula is CnH2n. We will come to that. Now, let's just draw them out. So we'll do cyclopropane first. We have C, we have 3 carbons, nice and easy. And then we have 2 hydrogens. Remember, every carbon has 4 bonds. That's cyclopropane. Okay. Now, I don't want to draw them all. We'll just skip up to cyclopentane. Let's see. This is going to be if you can remember how to draw a pentagram or a pentagon, you'll get something pretty close to what you want. And then, how does that work? And you can put a hydrogen on the end of every one. So this is an example of how to draw cyclopentane. It's done very quickly. I don't want to waste your time watching videos. You can go and look for more information and better pictures on the internet. 5 carbons, cyclopentane. Now let's just count everything up. How many carbons have I got? I've got 5 carbons, so it's C, 5, And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 2 hydrogen in every carbon. Yeah, so it's H10. Let's check this one out. 3 carbons, C3, 1, 2, 3, 4, 5, 6, H6. So there are 2 times more hydrogen than carbon. So if I was to take C28 as a cycloalkane, how many hydrogens would I have? Well, what's 28 times 2? Remember, here's our formula, CnH2n. Okay, so what's our formula? 28 times 2, ooh, that's good to test me. Is that 56? That's going to be 56. And there you go. I don't know what that's called. It will have a name. You can go and look it up. All right, off the top of my head, I have no idea. Okay, so cyclopropane, cyclopentane, you can draw out cyclobutane for practice, and you can draw out cyclohexane for practice, and you can look the properties of these things up. Some of them are used as propellants for aerosols now to replace CFCs, the old day when we were destroying the ozone layer. And I think that cyclobutane is used as a propellant now instead of CFCs, which were destroying the ozone layer and killing everyone with skin cancer. What they're used for is not really so important. It's just important that you recognize the structure and also note this general formula, CnH2n, because we're going to come across that structural formula, that general formula again when we look at something else. So you can have homologous series that have the same general formula and yet have different types of structures. So you need to watch out for that as well. The cycloalkanes have the same general formula as the next thing we're going to talk about in our next lesson, which is going to be the alkenes. They are also CnH2n, but their structure is very different and they have very different properties, as we'll see in our next lesson. So hopefully I've managed to do that in 10 minutes. You've got an idea of what the cycloalkanes are. If you haven't, pop your questions below or ask me if you see me. See you next lesson.